Welcome to part 2. So in part 1 I went through a little bit of a PowerPoint and went through the idea behind integration. In this video we're going to be showing you the maths itself. So we're going to be finding the area under graphs. So if we have the indefinite integral of f of x with respect to x, what we say is that the antiderivative is equal to capital F of x. So the capital F of x is the antiderivative of f of x. That is this one right here. This is an indefinite integral. If we are now doing definite integration, it would look like this, where we have our terminals. The way in which you would read this is what's the definite integral of f of x with respect to x between x is equal to b and x is equal to a. And to answer this, we're going to use our fundamental theorem of calculus, in which we sub in our upper and lower limits into the antiderivative and subtract them from each other. We're going to be seeing how this works in action. So let's not hold off any longer. Let's begin. So here is our first question right here. We're being asked to find the definite integral of x squared minus 3 with respect to x between x equals 4 and x equals 2. The first thing that we're going to do is just give ourselves a bit of a sketch so we can visualize what we're doing. So I have the function x squared minus 3, which has already been drawn for us right here. It's simply a parabola that's shifted down 3 spaces. We then have to look at our upper and lower limits, also known as our terminals. So here we have 4, so that means x equals 4 is one of our terminals. So let me draw that in here. Right there is what we're looking at. Just there. Not the straightest line in the world, but it's good enough. That's x equals 4. And we also have x equals 2. Let's see if we can draw in a straight line there. Perfect. That was great. X equals 2 is there. What we're finding here, what the question is asking of us, is to find the area between x equals 2 and x equals 4 and underneath the curve x squared minus 3. We're finding that area right there. Having now drawn it, let's shrink this down and do some actual maths. So that's just helping us to visualize what we're doing. But now let's actually do it. Let's find what that area underneath is going to be. Okay, so how are we going to do this? Let's zoom right in here. The first thing that we're going to do is we're going to anti-differentiate the function. How do we do that? We are going to go x3 over 3. So notice that I plus 1 to my power, then I divided by it, and my 3 is going to become 3x. Now, in the last video, I talked about the fact that you don't have to plus c if you're doing definite integration. So right here, I would say don't plus c. Don't plus c. Because we are doing definite integration. So you would not plus c. And I'm going to show you why you wouldn't. So you're not going to do this. I'm going to do it in red to show you that you shouldn't do it, but I'm going to show you why you don't have to. Okay, so once we've found our antiderivative, we then put it into square brackets, and I put my terminals here, 4 and 2. The next thing that we're going to do is we're going to substitute in our terminals into the antiderivative. So what we're going to do is my antiderivative is denoted with capital F. So I'm going to sub in my upper limit. Then I'm going to subtract when I sub in my lower limit right there. So let's now see what this actually means. So I'm going to do this, and then what I'm going to do is sub in 4. So I'm subbing in 4 into this. So I'm going to get 4 cubed minus 3 minus 3, 4, and I'm going to put this plus c in because you're going to see that it's pointless very soon. And then I'm going to do that. Now I'm going to subtract. I'm going to put that. Now I'm going to put 2 in there. So I'm going to get 2 cubed over 3 minus 3, 2. And then I've got my plus c again. And soon you're going to see that that's pointless. Okay, doing that like that. Perfect. We have done that step right there. So just to make sure that everyone's clear on what I've just done, I took my upper limit and I subbed it into my antiderivative just like that. Then I took my lower limit and I subbed that into my antiderivative just like that. And I'm subtracting both of those. So now all that's left for us to do is some maths. So let's do that. 4 cubed will be 16, not 16, it will be 64. It will be 64 over 3 minus 3 times 4 is 12, and then I've got my plus c here. We don't have to, but let's just keep this in brackets. Then I've got minus, and we have to put this in brackets, is going to be 8 over 3 minus 6, and then I've got my plus c here. The next step that we're going to do, you're going to see why putting in the c's is pointless. And soon you will see why the c's are pointless. All right, so we've got 64 over 3 minus 12 plus c. Ooh, let me do that plus c in red. Plus c. Now what I'm going to do is just expand out this negative. So bring that negative inside. So it's going to be negative 8 over 3. Then it's going to be negative 6, which is going to be plus 6. And then it's going to be negative plus c, so it's going to be negative c. Can you see why my c's are pointless? I have plus c and I have minus c. They're just going to go away. They're just going to go away. So that was pretty pointless because that's going to happen with every definite integration problem. The c's are just going to disappear. So that means it's a waste of time to put the c in there. You should not do it. So that's why when you're dealing with definite integration, don't plus c. Don't. Okay. Let's come down here and let's continue with the maths. The next thing that we're going to do is we have 64 over 3 minus 8 over 3. That's going to be 56 over 3. And we have negative 12 plus 6. That's going to be negative 6. I then am going to have to give those common denominators in order to do this calculation. So it's going to be 56 over 3 minus 18 over 3, and that is going to be equal to 38 over 3. So let's put that in now. That's going to be equal to 38 over 3, and that right there is going to be my answer. Now this is area, but we don't put a unit on it. We do not put area units on it. So that's our answer just like that. We have done our first question. Hopefully that made perfect sense. There is our first question done. Let's now move on to our next question right here, in which we're being asked to do the same thing. So we're being asked to evaluate the definite integral of 3x plus 4 with respect to x between x equals 3 and x equals 1. So as you can see, I've already drawn in 3x plus 4. It's just a straight line like that. I'm going to put in my terminals. So 3 is going to go here. Oh, I'm not going to be able to draw a straight line. Whoa. That is horrible. And then x is equal to 1. Oh, I even failed there. So what that's going to be, let's pretend they're straight. Let's pretend that they are straight. That's x equals 1. That's x equals 3. What we're finding is the area underneath this graph. So this area, we're finding the area underneath the graph. Okay. As you can see, my coloring skills are not very good. It's kind of hard to draw on this tablet. I've never mastered. I've been drawing on it for years and I still can't do it that great. Okay, we're finding that area right there. So having done that, let's now shrink that down and let's do some maths. So I'm going to shrink that down. X equals 1, x equals 3. Shrink that down there. Okay, let's do the maths. The first thing that we do is what? The first thing we do is we anti-differentiate 3x plus 4. So that's going to end up being 3x squared over 2 plus 4x. I don't plus c. It's just a waste of time. And I don't like wasting my time. This is going to be 3. This is going to be 1. Perfect. Great first step. Our next step is we're going to take the antiderivative. We're going to sub in our upper limit and subtract our lower limit. Just like that. Let's scroll down and let's do some maths. I keep saying that. We're going to get 3 squared over 2 plus 4, 3, let me put that whole thing in brackets, minus 3, 1 squared over 2 plus 4, then I'm subbing in 1 there, closing that off. Then we come down. I'm going to be left with, this is going to be 3 squared is 9 over 2 plus 12 minus 3 over 2 plus 4. The next step I'm going to expand out. Let's see if I can write a bit neater. I'm going to go 3 9s are 27 over 2 plus 12 minus 3 over 2 minus 4. That's going to leave me with what? I'm going to get 27 over 2 minus 3 is going to be 24 over 2 plus 12 minus 4, or positive 12 minus 4 is going to be plus 8. 24 over 2 is 12 plus 8. 12 plus 8 is, drum roll, 20. And again, I don't put units. That is my answer. Perfect. That one was a lot nicer. So just so we're all on the same page here, let's come up here. Let's bring down our graph and let me show you what exactly is happening here. What I'm saying here is that the area, my area is 20 here. So technically you could say it's 20 units, but you'd have to say like down the bottom there for 20 units, but you don't have to. That's your answer right there. That right there represents the area. That right there represents the area in the same way that, what did we find here? We had 38 over 3. 38 over 3 represents, or is, my area there, 38 over 3. We don't put units on it. Okay, there you go. Phew, let's keep on going. What's the next thing we're doing? We are here, it says, find the area bounded between y equals x squared, x equals 1, x equals 3, and y equals 0. Whew, there's a lot going on there. So let's start drawing these in. This one right here is obviously x is equal to 1. This line right here, I can't draw that. There's no way I'm going to be able to do this. Wait, give me a second. Wow, I've impressed myself. That's going to be x is equal to 3. And then we also have y is equal to 0. Y is equal to 0 is simply going to be the x-axis itself. Or this one might pose to be even more... that's pretty bad. But it will do the job. And also, y equals x squared. There's no way I can do this. There's no earthly way I could do that. Wow. It started off strong, then it just got real bad real quick. I can't do it. It's that line right there. And we're finding the area there. That's what we're finding. We're finding the area. Let me do that in yellow. We're finding the area bounded by all those lines. So we're finding this area right here. So also remember, where it's being bounded by y equals x squared. We now know how to set this up as a question. We would say, find the definite integral of x squared with respect to x between 3 and 1. We now know how to answer this type of question. We would find the antiderivative of x squared, which is going to be x cubed over 3. Chuck in our terminals, 3 and 1. The next thing that we would do is we would sub in the values. So what we're going to do is do the antiderivative of 3 minus the antiderivative of 1, which is going to be 3 cubed over 3 minus 1 cubed over 3. That, my friends, is going to be equal to 3 cubed is 27 over 3 minus 1 over 3, which is going to be equal to 26 over 3. So that right there, 26 over 3, is the area bounded by all those lines. That is what it is. So we've just got a few more questions of like that, and then we're done. So let's keep on keeping on. All right, 26 over 3, perfect. Now we've got this one. So it says find the area bounded by y is equal to 4x minus x, 4 minus x squared, x equals 0, x equals 2. I think the first thing that we should do here is actually sketch it. So let me come here and look at what I've made prior. Let me bring this up here as well. Come on. Okay, what do we have here? What we have here is we're being told we need to find the area bounded by y equals 4 minus x squared. So I've drawn that here. 4 minus x squared. I'm doing it. That's pretty good if you ask me. 4 minus x squared. X is equal to 0. X is going to be equal to 0 right there. It's going to be that line right there. And x is equal to 2. X is equal to 2. Oh, I can't do it. And y is equal to 1. Y is equal to 1. Oh, that's going to be the worst of them all. Come on. Okay, so that's y is equal to 0. That is x is equal to 2. That is x is equal to 1. And this blue line right here is 4 minus x squared. So obviously the area that is bounded by all of them is this area right here. It's this area right here. Okay. Having done that, that's just helping us to visualize what we're doing. We're finding what that area is going to be. So let's shrink that down and let's have a look on to see how we go. Okay. The first thing that we do is we're going to set up our integral. So what are we going to do? We're going to say that our definite integral of 4 minus x squared with respect to dx between 2 and 0, so 2 and 0, we're going to find the antiderivative, which is going to be 4x minus x cubed over 3. We then put our terminals there, 2 and 0. We keep on going. We now are going to, I'm not going to put in that step of the capital F's. I'm just going to do it straight away. I'm going to put the 2 into the x spot. So it means I'm going to be get 4, 2 minus 2 cubed over 3. Then I'm going to subtract 4, 0 minus 0 cubed over 3. So hopefully you can see what's going to happen there with all those zeros. This whole thing here is just going to disappear because I've just got zeros there. So that means what I'm going to be left with is 4 2s are 8 minus 2 cubed is 8 over 3. I then am going to have to do some fancy maths here to get this the same. I'm going to have to get common denominators. It's not that fancy, is it? It's just 24 over 3 is minus 8 over 3. So what am I going to be left with? I'm going to be left with 16 over 3. So let's write that in right now. So 16 over 3 represents the area bounded by all those lines right there. Let's see how far away I was from it. So that 16 over 3 represents or is the area underneath that graph. Okay, one last question to go. One last question to go. We're nearly there, guys. All right, here we go. It says find the area bounded between y equals x cubed minus x. That's the blue line right there. I'm not going to draw it. Then we've got x is equal to 0. X is equal to 0 is going to be this line right here, this straight line going there. Then we've got x is equal to 1. This is going to be x is equal to 1 right there, that line right there. And we also have y is equal to 0. Y is equal to 0 is just your x-axis right there. The area bounded by all this is actually here. Why is this different to the previous questions? It's different because I'm underneath the x-axis. How is that going to make my answer different? Well, hold on. We're going to see how. All right. That was such a better way instead of drawing out the lines like a Muppet. I couldn't do it. Okay. There we go. There. Actually, let's just put it over there. Let's make it big. Let's just put it there because we are going to come back and look at that because we're finding area underneath the x-axis. My goodness, what's going to happen? All right, so what are we doing? We are finding the definite integral of this function right here, x cubed minus x with respect to x between 1 and 0. I therefore am going to anti-differentiate this thing right here, which is going to be x to the power of 4 over 4 minus x squared over 1. Then I'm going to do this. Then I'm going to put in my terminals like that. Now what I'm going to do is sub in both of them. So I'm going to get, now 1 to the power of 4 is just 1. And 1 to the power of 2 is just 1. Then I'm going to subtract. Now it's always great when your second terminal is 0 because what I'm going to end up with is 0 over 4 minus 0 over 2. That whole thing there is just going to go away because of those zeros. So that means what I am left with, what am I left with here? I have 1 over 4 minus 1 over 2. I'm going to do my calculations. A lot of you would be able to do that in your head straight away, and bravo to you. But if you're thinking, oh gosh, I don't know how to do that, remember, you're just going to make the denominators the same. So I'm going to times that by 2. So it's 1 over 4 minus 2 over 4, which is going to be equal to negative 1 over 4. which makes perfect sense. All right, there we go. So that -1/4 represents the area underneath the curve. So hopefully, I said that the answer was going to be a little different because we're dealing with area underneath the curve. And as you can see, the area is negative. And that's because I'm underneath the x-axis. Because I'm underneath the x-axis. Did I say the curve? Because I'm underneath the x-axis. Because I'm underneath the x-axis, my area is negative. That's what we call signed area, and that's what our next lesson is going to be on. But right now I'm tired, and I'm just going to take a 10-minute break before I record the next lesson. All right, I will see you then. Hopefully everything I said has made sense. Bye-bye.